So hey guys, and welcome to another YouTube video. So in this video we are going to be talking about lists and sets. So let's actually get started with sets. So what is a set? A set is actually a collection of items, and these items literally have some conditions. Like a set literally has some conditions, right? So the first thing is these conditions, these are elements that we have, right? They have to be unique. So if we try to add an element, to say we have added an element in a list, and then we try to add that same element to that same list, that element will not be added to that set. Why? Because a set is only going to contain unique elements, right? Then the second literally condition that we have is in a set, the elements are not sorted. For example, when we're talking about arrays, we literally knew that at position 0 we had an item, right? Where that would have put on position 0, and if we put an item on position 1, it stands there. We put an item on position 2, it literally stands there. It won't change. But here with a set, it is different. A set is a collection of unordered elements. That means those elements do not have positions, but they literally exist. So you literally need to be careful when you're using a set, because you won't be able to track where your element actually exists in a set. So the definition of a set, we have a collection of unique elements which are unordered, or a collection of unordered elements which are unique. I don't know how we have to put it there, but let's actually get started and see how we can actually create a set. So to do this, let's do set, and then these tags, and let's go on to say that is a integer, right? Wait a moment. All right, like this, and then we do new. Let's have what do we have to here? A hash set like this, and then we put integer like this. Let's go on like this, and right, what happens? Not like that one, right? So you see we have these errors. Why? We literally need to import this, let's say from you import java dot util dot what we need to, like this firstly, and then let's go on to say import java dot util dot, and then hash set, like that one. And then what is it saying here? The integer web class wraps a value of the point to type int in an object like that one. Right, just want this, and just make sure what will happen here. Variable declared. All right, we have to put the name like that one. I don't know how I did forget to put the name there, but anyways, that is the syntax to actually create a set. So another information about a set. Set is actually faster. Like when you're adding an element, it just adds like real fast, like instant. So just adding an element. When you're removing, just fast to remove an element from a list. And when you're actually what we said edging, we're actually removing, or we are actually looking for an item in a set, then you literally get almost instant. Whether you have one item, or you have 5 items, or you have hundreds of items in that list, when you're actually searching for something to see if it actually exists, you'll get it, the results almost instantly, right? So how do we add an element to a list? So our list, we said, is named X, right? So we do X add, and then our list contains is of our type integer, right? So we literally need to add integers only. So we have added one. Let's do X dot add, and then let's put 4, and X dot add, let's put 8, like that, and let's repeat something. X dot add 1, and then let's go on to print our list. System dot out println, and then let's print X. Now if I run this, look what's actually going to happen here. We have 1, 4, 8, and then when we actually get to add one again, that one is not added to the list. We literally add nothing added. Let's run this again and see what is going to happen. We have 148. Let's run this again. Right. Okay. Let's go on. I think demonstrate something. Let's go on and add 56 x dot add, and let's go on f0 like that. X dot add -8 like this. Let's run and see what's going to happen. Right. Exactly what I needed to explain. Firstly, we added 1 to the list. We added 4, we added 8, added 1 again. That 1 is not added because a set only contains something which is elements which are unique, right? And then we add 56, we add 0, we have -8. But remember what we said before. In a list, elements are not sorted, right? So look here. We firstly added 1, right? And here, what we had 0. So these elements, to say they are literally do not have positions. Like in an array, if you add an element to say 1, then you add 4, we literally knew that 4 will be at a position which is before like 1, to say the first element in the array should have been 1 and then 4, like that, in that manner, to say one after the other. But look at here, we literally have 0, 1, 4, -8. -8, we added it as the last item, like in our code here, but it is here like on a certain position. Let's literally run this and see what's going to happen. Going to take that position again. Let's keep on running and see. I hope we'll literally get some better something which is okay. We keep on getting the same elements structure here, but I hope you actually do see what I was trying to say there. Now let's go on to say if you want to remove an item in a set. So x dot remove, let's remove what? Let's remove 8 from them. So if I run this, we will literally remove 8 from that list. Now see, we have 0, 1, 4, -8, 56, and we do not have 8 in that list. Know what happens? We can literally get the size of that list by doing x dot size, like that one. We need to be the function, and then if we run this, check what's going to happen. Okay, we have 5. Why? We added 1, right? So let's literally write it. We have 1, and then we have 4, we have 8, and then 1 is not added, right? Then we have 56, we add 0, and then we add -8, then actually remove 8. So what do we have here? We have 1, 2, 3, 4, 5 items in our list. So there's another method that we can actually do if we want to search an item in a list. We can do, so let's go on to say here x dot contains, if our list contains 50. Let's see. Okay, we only need this. So if we run this, what's going to happen? Obviously it's going to print false because 50 doesn't exist in the list. So let's do this boolean, and then we put what? Let's just put status, no status, but boolean exists, and then let's do x dot contains, then 1, like that, and then let's literally want to print exists in here, because we can literally store the value in a variable, and then what's going to happen? It's going to print true. Why? Because 1 exists in the list. Let's say we no longer want the values in that list. What can we do? We can literally empty the list by doing x dot clear, like this. And then if we print x, what are we going to get? We're going to get an empty list, like that. So for sets, I think that is it that I wanted to show, but we can literally have something, okay, which is like this, a tree set. Let's go on to, let me just show you one time. It's a tree set like this. So if I run this, what's going to happen? Okay, nothing. Why? Because at the end, we cleared the array. We cleared not the array, but the list. Let's remove that method to create the list. And then let's run this and see. Right. So when you're dealing with a tree set, those elements in a tree set are actually ordered. Like they have some sort of an order. Like they literally have an order. They will be ordered like from the smallest to the highest, to say small, and then something which is high. And then, so what is it? We have -8 here. This is the last item we added, right? But let's put it in the video to say like this. And then what did I do here? Okay, so I need to run this one more time again. Right. So you see, we have -8, we have 0, we have 1, we have 4, and then we have 56. So when you're dealing with a tree set, then the elements are literally sorted. And then for list, that is it. Let's go on to, not for list, but for sets, let's go on to looking into lists. So when you're literally looking for those lists, let's go on to print an array list like this. Let's type in integer, let's put in x, oh, it has to be in caps like that. And then this is new array list like this, and then we put integer like this, and then we go on like this. What do we have to do? Array list like this. Okay, that is it. So what do we have in an array list? What do we have? We have pretty much identical methods that we had on sets. Then we can actually add one like this. We can actually add an element to say probably 5, and then let's add something before we discuss a lot about them. We add 1 again, then x dot add what? -8, right? Like this. So when we're dealing with an array list, sort of like an array, but this array literally grows. If you add an element right to it, it literally resizes its size and grows. And if you remove, it literally adjusts its sizes and shrinks depending on it actually grows and shrinks depending on which type of operation you would have done on it. But this list is actually slow, like actually slow. So let's say the more much the elements you have, the slower is actually going to be to perform whatever you want to perform, and generally they are literally slow. So let's go on to print this, because some things are better off done than said. Let's print this. Okay, we have 1, 5, 1, and -8. So in an array list, the elements are not unique, right? To say in a set we had a collection of unique elements, right? But in an array list, they are not unique, right? So let's see how we can literally remove an item. We can literally remove an item from where, right? So let's remove 5 like this. What's going to happen if I run this? Okay, we have an index out of bounds exception, right? So when I'm dealing with an array list, we literally have to provide an index, not to provide a value like what we had on a set. So here, look at this. We had 4 elements, and then the index which is going to be the length of that -1, which is the upper bound index, is actually going to be 3. So let's remove something which is at position 3 like this, and see what actually going to happen. Right, we have 1, 5, and 1, and -8 is removed, like this. Let's say we want to put an element in a certain position. We want to update an element in a certain position. We use this set method, and then we provide the index. Let's say the index is 1, and then we provide an element, say 15. Then let's put it on index 0. I think that will actually do. And then if you run this, what's actually going to happen? We have 50, 5, and 1, because here we actually had to set an element to say at position 0 we need an element 50 to be put there. Now let's go on to do something like this. Let's go to print x and then do a get, and then what, on position 1, what is actually going to be printed out? Well, we are supposed to get 5. Yes, we have 5. Why? Because here we care about the position in a list, and it's array list. We actually care about the position of the elements, right? So we can actually what can we say? We can actually refer to an element by its index, right? Naturally point to an element using its index. And then here by doing get, we want to get, what is it? Position 1. And what is the position 1 is 5, like that. So there is another type of list that I can literally show you, which is a linked list, like this. I'm not going to talk about that linked list, but I'm going to do something like this, linked list, like that one. So I have a quick fix here, import, yes, and then let's run this and see what's going to happen. Right, so everything is working fine. I'm not going to talk about this linked list because it's something that can actually get complicated if I try to explain it, so I don't want to confuse more of you. But that has been it, guys, with this video. I'm actually going to wrap it up here. Don't forget to share the video if you find it helpful. Share it to someone that we can literally find it also helpful. Don't forget to hit the like button, subscribe to the channel if you haven't done that, and I will see you in another YouTube video.